All right, thank you guys for joining us for using ArcGIS REST JS and the REST APIs. My name is John Gravois, joined today by Dave Bowman and Tom Wason, my illustrious colleagues. We work on ArcGIS Hub, and today we're excited to announce a new open source project that we've been working on. We're using it behind the scenes at Esri, and we hope that you find it useful too. Just before we get into the code, we got a lot of demos to share. We're going to run some code and talk through some syntax, but before we do that, we need to have at least a little bit of a background, set some context. We'll talk about some of the projects that preceded Esri ArcGIS REST JS, what we learned, and sort of how we've adapted and why we're doing things now, and then we'll get into some demos. Basically, the one-stop shop, the most important links to remember are they're all open source. So we've got a GitHub repo, Esri ArcGIS REST JS, and then the documentation we host in the same repo, so you can look up the doc at esri.github.io, ArcGIS REST JS. And this project is, we're all on the Hub team, but this is actually a collaboration between a couple different teams at Esri. We got different folks using it. In particular, Patrick Arlt, who you may know from the R&D team in Portland that works on developers.arcgis.com, has made a bunch of contributions to this library. Noah Mulfinger as well. We've got a couple other contributors already at Esri. Max Payson from the startup team. And Hogpilot is the GitHub handle. We don't need to talk about Bill Reynolds' name because he's got the best GitHub handle of all of us. And then we've also had, this is a project we consider to be in its infancy, but we've already seen customer contributions. A guy named Ian from the Department of Fish and Wildlife up in Washington State, and Jeff Jacobson from the DOT in the state of Washington. They've already made a couple of just amazing contributions. So I want to send out our appreciation for that. And tell the rest of you in all the other states, Washington's, they got the game right now. So the rest of you are gonna have to step it on up. All right, so disclaimers need to be made. ArcGIS REST JS is not a product. It's not ever going to be a product. It's not something that has a product life cycle. It's a real sort of genuine, organic open source project. With the exception that if you log an issue, you're trying to talk to us, you're not going to get a troll coming out of the woodwork and being a jerk or just get ignored. So in true Esri fashion, we're trying to maintain sort of that good community and be positive and constructive. So hopefully that's helpful. So we've got the project on GitHub. Here you can see we've got it on NPM as well, so you can download NPM packages. Before we kind of get into the architecture, how it works, talking about where we came from, what we did before this to get started. How many of you guys ever used Geoservices JS? This is an older generation node library that we put on GitHub that had wrappers and methods for doing geocoding, working with feature service. This is something that runs in Node only. Node ArcGIS is another project. Basically, the landscape is littered with people who had the hubris to write a JavaScript complete wrapper for the ArcGIS REST API because it's expansive. So some folks have started libraries and abandoned them. I think all of us in our apps have found the need to just wrap our own XML HTTP request to fire off something, and because we didn't want to use another library, we did something purely for the app. So REST.js, we're trying to solve that problem or get some collaboration on some syntax that everybody can get behind and make a really bulletproof low-level wrapper. This is like bare metal that you can use so that you don't have to handle those details of checking the status code of for 400 and start to write your logic. So this is a modern thing. The goals of the project for us are we wanted to have something that was agnostic between running in Node.js or the browser. We wanted it to be small packages that were a la carte, so you can mix and match only what you need and not need to grab anything else. We wanted to make sure it was framework agnostic. If you're writing something in React or in Ember or Angular, or you use one set of properties or something else, we didn't want there to be a lot of opinions in this library. We wanted it to plug right in all the places people were using. And we wanted to sort of make a nice sort of UI for JS developers to make those REST requests, get the responses that they were expecting, and get on with their work. In a way, I think that this project has a lot of synonyms, or it compares pretty well with the ArcGIS API for Python, in that it's web-centric. It's helping you sort of interact with your items in ArcGIS Online and do some of those tasks. It's supplemented by a lot of other open source libraries, so there's not a ton of, and I wouldn't say there's not a lot of utility, but there's not a lot of functionality here, but it pairs well with a lot of other things that you might use. And it's vastly different than the ArcGIS API for JavaScript in that there's no mapping component. All of the rich sort of client-side visualization and analysis you find in the JavaScript API, that's not here, and it's not ever going to be here. Just to give you some perspective on kind of how small this is, what we're talking about, these are sizes of gzipped UMD builds of the library. You can see just making requests is just a couple of kilobytes. Some of these other packages are under 1 kilobyte. So these are really small, they're really lightweight. They're also small because they're not feature complete. You know, we're using this project to scratch our own itch in terms of some of the use cases in ArcGIS Hub and Open Data for how we interact with items in ArcGIS Online. The developers website team, I don't know if you know, they do a lot of feature service administration behind the scenes. They're making a lot of calls in pages that don't have a map. So we're building out the functionality that's useful to us. We're writing some other wrappers for things that are commonly useful, but this is not in any way feature complete or meant to be sort of authoritative and cover the entire breadth of the ArcGIS REST stack. So just to jump into a little bit of code and talk about just some snippets to give you an idea of kind of the ergonomics of the API.
Okay. Can you guys read it?
You good enough code-wise in the back? I think we're all right. If anybody, you good? All right. So this shows if you want to do some geocoding, you know, you're going to turn some text into locations. REST request is the lowest level lib in the package. So everything's in the same project in GitHub. We use Lerna. It's a monorepo, so there's isolated packages that we do all the version control in the same place. So you have to mix and match everything that you're going to use. So if you're using geocoding, you have request as well. This is a node syntax or sort of ES6 JavaScript syntax. You can import just that function and then pass a simple string and get a response. So this is promise-based. Under the hood, we're using an implementation of fetch. So if you don't have fetch, there's some other shims that you're going to need to use to get going. We're kind of prioritizing modern evergreen browsers and modern versions of Node.js. It's, you know, low level, there's not a lot there, and we're prioritizing sort of the simple use case first. We're also trying to sort of keep the jargon sort of to a minimum and use as simple a language as possible. So another geocoding example, reverse geocoding. If you've already got a latitude and longitude and you want to figure out, you know, what that location is in place, you can pass an array. But you can see we've got an overloaded constructor here. So if you know latitude and longitude as a JSON object literal, you can pass it that way. If you are working in another projection, you can pass the spatial reference. Those are all optional. So we have a really concise syntax first for what we think are the most common use cases, but it expands and gives you more options as well. To take that a little bit further, I'll switch to a browser-centric code snippet instead of Node. Here you can see we've got from the NPM packages, you can just use that CDN unpackage.com and get request in geocoder and your polyfill if you need to support an older browser. Here you can see we use ArcGIS REST as the global, and then all of the methods in all of the packages, they're all spawned off of that same global. So the implication of that is the organization is good, but the implication of that is between the different packages, we have to make sure to not have any name collisions. So the method names sometimes get a little bit longer because we need to differentiate the method in one package, not just from all the others, but from other packages as well, if that makes sense. Here's another example for suggestions. If you don't just have a raw string, you need to pass some more parameters and get a little finer grained control. We pass the string in the first argument position, and then this object has a whole lot going on in it. If we want to pass, instead of a get request, we want to make a post request, we can pass that. And then there's this generic placeholder, this params object. I put that in there on purpose because that is kind of a backdoor. It allows you to pass any request parameter that you want. You don't need to worry about doing things like saying f equals JSON because we know about that automatically. But you're not sort of worrying about, we're not making sure, the surface area of the API can be open-ended. It can sort of give you some other options as well. And I'll show an example here from the API reference to give that a little more sample here. So we got some guides in the API reference. You can step through it here and see the different packages. Here down in Geocoding, I think that's at the bottom. REST request. Here it is. Suggest, we've got partial text as the first argument as a string, and then I suggest request options as the second. And this doesn't look familiar, it seems a little weird, it seemed a little wonky to me at first too. This idea of interfaces, so we're writing all the code in TypeScript, and then we're compiling and shipping UMD modules, so you don't have to use TypeScript. As a consumer of the library, you can use vanilla.js, you can use it in Node. If you are a TypeScript developer, you'll get all the benefit of the typings because we're sort of creating that structure of what the individual requests and responses look like, but you don't have to use them. So these interfaces, I suggest request options, just extends I endpoint request options and then I request options, which is something that's generic in the whole library. So you can traverse the whole API and see how all that works. I wanted to show an example that was selectively kind of, I wouldn't say it's an ugly spot, but this syntax is a little wonky because it gives you a backdoor to do whatever you want. And that's something that we're utilizing heavily because we haven't built out the whole thing. I worked on this geocoding package, and I wanted to sort of also give a shout out to a developer that worked on a library before. It's called Geocoder ArcGIS. This is just a standalone promise-based lib for geocoding that we borrowed some of the syntax and the sort of API design because GeoServices.js before was callback-based and now switching to promises. I really like this lib, so I borrowed from it as I was sort of designing out and mocking some of the rest. So it's a really good project as well. So I got one demo before I pass it off. I might do it on time, 15. I'm actually doing all right. So I'm going to show a sort of like live running code. This is batch geocoding. So here, this is in the ArcGIS REST JS project. I'm going to traverse my way back here so you can find it here. There's a lot going on in the GitHub repo because it's a mono repo, all these individual packages. But all of the source code is in the packages folder. And we've got a whole bunch of demos that we wrote and customers have contributed as well that show the library working in different contexts. And the one I'm going to show right now was one that Max Payson originally wrote on the startup team. And this is just a simple node application that takes a CSV that has addresses in it, chunks up the individual blocks of the rows in the CSV, makes batch geocoding requests, and then writes a CSV output that has the latitude and longitude locations. That's all it does, and it does a good job. So this demo here, the thing that's the most important, it's only about 100 lines of code. The first thing that we do in this library is require in isomorphic fetch and form data. This is a requirement in Node. Bigger. Up doesn't always mean louder. All right. Fair enough. No, I appreciate it. So isomorphic fetch and form data are prerequisites in Node to get that sort of modern implementation of making the requests. He's got another library in here for parsing the CSV. And then this from ArcGIS REST JS, we pull in REST auth to do the authentication because batch geocoding requires you to pass a token. And then geocoder. And we're just going for this single method, this bulk geocode. So here there's some code for parsing the CSV and exporting it. The stuff that I wanted to pay the most attention to or talk to first was this idea of how we actually do that authentication, how REST.js makes that a little bit easier than if you're doing it manually. Here, we don't put the username and password right in the code. It needs to come from a config. But ultimately, we just pass through a string to this new user session. And then that session that gets instantiated goes in when we call bulk geocode. We pass a single object with the chunk of addresses that we want to get converted, and then that authentication parameter takes a session. That could be either a user session or an application session. So I showed you a lot of examples before where we had like a string or an array. We had a simple use case, and the first argument was just something like a string. In this case, it's just one object that we passed to bulk geocode. And the rule of thumb we're using in the library so far, we're still trying to sort of make it consistent. But the pitch that I made was, if we can help you fire off a request and we only need one piece of information from you, that will be the argument that gets passed. And other options will be in the second position and optional. When we need two pieces of information from you, you'll just pass them both in the same object. And that's like what we're going for as a way to be consistently inconsistent. And this is a good example. You can't bulk geocode unless you give us both the addresses and authentication, so they get provided in the same object. So this is the code. There's only about 100 lines here, but I could show it in work. You can see that I did it half an hour ago just to make sure I wasn't going to blow myself up. And then looking on disk here, you can see the inspection results. Those are included in the lib. If you want to run this yourself, you can do that. The config template, I made a copy of that and pasted my username and password into it. And then the geocoded addresses are what came back. And we just have about 100 records here, but you could use this on a really big data set because that chunking is going to break it up into sort of manageable bits for the REST API to handle. And here at the end, we've got this X and Y, the score of the geocode, and the match type. So this is just one of the demos, and there'll be more we're going to show you here, the rest. That's all I got, I think. Let me make sure. Not that one.
I think that was it.
That's it.
That was your demo slide. Cool. So now we're going to press a button here and hopefully it switches.
I will confirm that.
You will confirm? We see something different. Okay, cool. So we're basically going to be covering different sections of the API as it exists today. So one of the areas that I worked on was bringing in stuff to deal with items, the baseline capabilities. And so, again, this doc stuff, and I'll give another shout out to Patrick because he built all the tooling in this repo. But basically, as we write the code, the doc gets generated automatically. If you want to see an example of a really maxed out tooling repo, this is a great one to look at. We've got all kinds of stuff in package JSON to do automated everything. It's phenomenal. I don't even think we can do a pull request unless we have 100% code coverage. There's gating all over the place. It's really pretty impressive stuff. But anyways, so you can check that out. So I wanted to talk a little bit about this part of the API. The first thing you need to do with items typically is do a search for them. So the API, again, we try to make it really simple. So search items, you got to require that in, bring it in. And then if you just pass a string, great, it's just going to do that, right? This is an unauthenticated request. It's just going to use a very generic query to the ArcGIS online or portal search index. It's just Q. If you've used any of the APIs directly in the past, you know you can pass all sorts of interesting things into stuff as the Q parameter, so you can put in types and type keywords and really get expressive with this, so you can give it a query, but I only want web maps and they have to have these type keywords and these tokens in this org owned by John, sort of thing. If you need to get more expansive than what's available there, like if you need to do paging, then we get into the whole thing of actually passing a larger object hash down. And the details of all of this would be over in our REST API docs, all of these different things. So if I did search items, we can see it's an iSearch request options, and then this is all the stuff you can pass in. Now, at some level, you may be like, oh, that's a whole bunch of stuff to pass in. But what we're trying to do here is enable you to have a lot of control. So if you're working against an on-premise portal or an ArcGIS enterprise instance, you can pass the portal string along. By default, the library is going to assume you want to talk to arcgis.com. But if you need to override it, that's why we provide all this other stuff. If you have a particular library and you have your own fetch implementation, you can pass that into this. So there's a lot of stuff in there. There's control over post versus get and maximum URL length and a lot of capability there, so you have control while still providing a very standardized input. So the actual search form, it's the Q, the start, and the number, and you can work from there. So taking it another step further, an example showing searching private items on your portal. You set up your user session, kind of like John showed. That's going to know all the details about how to manage tokens across federated servers. It's kind of like the identity manager, a really thin wrapper over that same kind of core set of logic. Is inside these user sessions. There's also an app session corollary to this that you can pass into this same spot. Again, because it's TypeScript, right, that's the I authorization manager interface or something roughly like that. So we have the two implementations of it and the portal URL. So that's that. Obviously, we'll go over the rest of the API. I don't want to drag you through the mud on it, but we have basic CRUD operations, so we can create an item, get an item, update, and delete an item. On the create, something that should be noted here is that you can create the item and send the JSON data at the same time. And the create item method and all these things are going to handle this for you. So if you just create a new item and it's just you go put in your normal metadata hash, the title, the owner, description, that stuff, you can then also tag in the data right into that same object graph. And what will happen is during the serialization, this is the serialization function just lifted right from the code base. We make a clone because we need to move some things around in here. But ArcGIS Online's API, it wants the type keywords sent as a comma delimited string. But we in JavaScript want to use those things in arrays. So this is the sort of stuff the serializer is going to handle for you, and it will handle it on any update or create type function. If you have a .data property, it's going to do the JSON stringify of that, tack it into a text property, which is more in line with what the actual API wants. Same deal with item properties. For those who don't know, this is a really handy little bag of holding. You can go shove anything in here you want, and then when you do a search, you can get this information back, and you don't have to do like an n+1 query where you get your 10 search results, and then you issue 10 more requests to go get the data that backs it to go find some information. So we make heavy use of that, but that's also handled in here. Other itemy things that you probably want to work with, if you want to create the item itself and then do some other work and then add the item JSON, we have a method for that. Creating items in folders, again, API ergonomics, we just have a separate method. And then the ability to go get the item data as a separate call. Resources and protection, this stuff is in here now. The asterisks are because at this point we're only currently supporting sending up text resources, so you can go and push text files, CSVs, or JSON resources into the item, and we have protecting and unprotecting. Very shortly, we'll also be adding support for images, and this is really being driven by as we convert parts of the ArcGIS Hub and the Ember libraries that we use over to using this as their underlying code base, we need more functions. And so that's going to be the forcing factor to get these things in. The groups API, we can search, create, get a group, update it, remove a group, and then you've got other groupy related things saying, get all the items that are in this group, get the users that are a member of the group, and then group protect and unprotect them. Which these are really handy things if you didn't know that you can protect a group so people can't delete it. If you're doing anything with shared editing through group membership, it's pretty handy not to have somebody just delete the group and then bang, a whole aspect of your collaboration falls apart. So this is a simple example in Node, just, it's almost exactly like what John was showing. Bring in isomorphic fetch and form data because those are needed. Requiring things without assigning them to a local variable basically loads them into the global scope in Node. So you only need to do this in one file in your Node application. Normally, whatever the one is that you start first, and then it's around and ambient, and then any place in the library that needs it can access it. Again, creating a search form is very straightforward. So the demo that I wanted to show, this code, the one I'm going to show initially, again, is in the repo. You guys can go and mess with the code. It's built with a library called Commander. The idea here is to allow you, by using Commander, it gives you a good setup to go build your own command line tooling and infrastructure to help automate your tasks. So stuff you might traditionally do with the ArcGIS Python API, But if you're a JavaScript developer and you want to write the code in JavaScript, this is the exact way you would do it, right, to use Commander.js. So that's a library that's involved here. So let's swing over to this. Is that pretty good? Text size? We're good? All right. So what do we have in here? This is just about setting up Commander. This is creating a command called search and another command called export. And then the actual implementation of this is up here in lib. And then we have 2 actual commands. And so what's cool about, I thought kind of handy about giving you this as an example is that it's very easy for you to go create more commands and then attach them in. And then you have a local command line tooling system that you can work with. And so what does this look like? So I can go like AGO -- help, and it will tell me, oh, look, hey, I can query or I can export. So we'll do AGO search for water, and it barfs back these. At this point, how useful is this? Probably not, but you can expand it to, go and do the searches however you want. So if you wanted to do like water and actually it's like and type web map. So now it went and got me a bunch of web maps, and then I can say, okay, I want to make a copy of this web map for some reason. Export, and we'll do the dashboard. I don't know what this guy is. .json. And so that just fired it off, and then if we just cat tst.json, like there it is. Okay. So, on its own, is this the most useful thing in the world? Oh, no, of course it's not. But it's mostly just setting you up to say, this is how you use this stuff. You can build your own tooling. And so I wanted to kind of talk about a tool that we've built as part of the ArcGIS Hub team. So the Hub is a relatively large application. We're still under active development, but hopefully you're starting to hear a little bit more about it. During our development process, we run end-to-end tests. And so part of our CI development pipeline is that once everything is merged, it gets deployed, and we run a bunch of end-to-end tests using WebDriver IO. During that test run, we create an awful lot of items. We create these sites and initiatives and a whole bunch of things that get created. And like any end-to-end testing situation, it's real data. It's live stuff. It's out there. We don't do it against the production environment. We have a QA area to do this in. But still, we're actually creating things that live in an ArcGIS organization. Now, we'd like to tell you that our tests never fail because we write perfect code. But that would be a lie, right? Occasionally these tests are going to fail, and when they fail, they leave a whole bunch of detritus lying around in this organization. And we need a way to clean it up in an organized fashion. And that's what we built, is this command, hello, hub help. And essentially it's called purge. We give it a username, a password, and an org URL, so I'm not going to run this right now. But it will just roll through that organization and kill everything owned by that current user, but it will very gracefully and specifically remove some of the very complex items that we create as part of the hub. So when we create a site, like an open data site, it doesn't just exist as a single item in online. We have other back-end systems that are related to that, like how we do the domain resolution and crosswalk between an item and the URL that you attached it to. So we have to take something out of the domain service. We have to clear out all of the open data back-end indexes that are created for this thing. So we need to do that in a very methodical way. And that's what we've used it's Commander, and it's a whole bunch more code, but that's the sort of example where we're using this command line tooling to help us clean up after ourselves when our tests fail, so that our org is always in a good state. So that was, talking about the item stuff. Dom.
I haven't tested this mic yet. It sounds like it's not. Is that better? Can you guys hear me? Okay. So in addition to being able to geocode and work with items, we also interact with feature services, and not always in the context of a map. Give you an idea what I'm talking about here. If you go to an open data page, you'll see this list of attributes here, and you'll see these little symbols above some of them that indicate there's a little chart symbol and a little dot symbol, and those indicate whether or not you can generate a chart of the distribution of that attribute, so you can kind of get a sense of, you know, helping people explore open data, whether this is something they want to download. And we don't, how we just generate that chart, that distribution, how we decide whether or not a given attribute is chartable, is based on some things that we have right there, some of the field metadata, you know, what type of field it is, but it's also based in part on statistics. And you get some data sets that have dozens of fields. We don't want to run all those statistics at runtime every time someone hits this in the browser. And so we had this node process that Dave wrote that we call somewhat ominously the harvester. And whenever an open data set is updated, the harvester runs and fetches these stats, and we store these, we cache them away, and then when we open up, when people hit the page in the web app, they're seeing the cache stats, which is really hard for me to say because on the team, Marvin started calling them stashed cats. And so every time I was running through this demo, I was like, I know I'm going to say stashed cats, so I need to just put that slide in here so that if I do, everyone knows why I did. And I actually made it without saying it. So anyway, that's a stashed cat. But another thing that you see right there in that example of that page is that we had, you know, the charts are created with an external library called Cedar, which I'll show you right here. And the thing is that in that page, yes, the context, there was a map, the JavaScript API was there. Cedar can use that to query the feature service. But Cedar, you know, it's about charting. It's about data visualizations that are not map-based. And so Cedar needs to be able to make requests to feature services without necessarily requiring, you know, a map be there, or without necessarily requiring the JavaScript API. So we have these external libraries that, you know, are not always running in the context of a map. So we wanted something that we wanted to expand the REST JS with a way to interact with feature services. So we have a package in there called ArcGIS REST Feature Service. It's the youngest of the packages. It was released on Saturday night in a fit of conference-driven development. So it's a little limited. If you go to the API, there's not as much as you saw with Dave's there. We basically have a couple of read-only operations. We do plan to add CRUD operations. We have a use for this in the hub. And we mentioned that the developers.arcgis.com site does a lot of feature service administration. They're going to create some administrative services for feature services, which might end up in its own package, such as feature service admin, something like that. But how's that look for code size? Good? So just to give you an idea what that looks like, you import, we have two functions so far. One of them is get feature, and that will make a request to a feature layer with appending the ID, the object ID of the feature onto the end of it. So if you happen to know the ID, you can basically get the attributes and the geometry back. A more useful function, one that we're using in Cedar now, is query features. And that's going to hit the query endpoint of the feature layer. And you can pass in all of the query params that are supported here in the shiny new REST API doc. So we support all of that you guys know, all the things you can put on that page with the form. And it's going to return essentially the feature response, the JSON response you're probably familiar with, a feature set that has a property called features with an array of features, as well as some other, if the feature service supports it, the other metadata about whether or not, there are more features beyond what you queried. So let's take a look at that, and we'll take a look at another sort of context in which I think, why you would consider using this in a web app. So one of the things the hub has is the notion of events for, these are not events as in mouse events. These are events as in public gatherings or anything that the city or organization using the hub wants to try and engage with their community. And they might have tree planting events, or they might have meetings, council meetings, that sort of thing. And so one of the things we're trying to do in the hub is get developers to start meeting the citizens where they're at, which is on their phones. So you can imagine a hub events app that would search for events and find one. And this thing doesn't need to get up in your face with a map at the very beginning of the whole process here, because there's a couple ways people search events. One is what's happening around me right now. I'm a party. I'm just like out there at a party. I want to see what's going on. That's not me. I'm more interested in finding out what's going. What is the city doing that is in an area that I'm interested in. So I started working on this app this morning at about 8 o'clock, and it exists. It works. And it uses the APIs just like we were showing there. And I learned a few things. One, the query features inside the hub REST.js works really well. The other thing I learned is I'm not very good at React and Preact and JSX. So if anybody wants to go check out the code for this and help and fix it, make it a little bit cleaner, it's there. It really just does it does exactly this. These code snippets are pretty much taken directly from there. We can also, though, use it in, we can also use the, we have inside the REST.js repo, we have another one of these demos that is a vanilla JavaScript. Looks a little small. Is also vanilla JavaScript. Is not made with Preact. Doesn't have all the fancy. Is not using ES6 import statements or any of that. So this is just a simple thing where you can search for trees where the type is a certain. It's a very contrived example. You can change the query parameters here to update how many results are returned, and you get this indicator that there are no more results down here. So we'll take a look at the code there, because it's a little different than the code snippets I showed you before. I'm going to blow that up, don't worry. So the main thing is, just like John showed earlier, that instead of doing those import statements, you're going to be pulling the code via, from a CDN or from some, you need to bring in the packages. And here you need to specify, both feature service. Like the other packages, depends on requests, so you want to pull that one in first. And then the real work is done down here in this query trees function, which is going to again use that ArcGIS the global ArcGIS REST. It's going to call the query features function, pass in the URL and the params, and we have the where out fields result record count. Which is going to be used to limit it to a certain number of trees per page. So those are the demos for feature service. Like I said, that is a work in progress. That is brand spanking new, but we laid the groundwork, and we're already using that inside of. It's actually one of the ones that we're already using. We have. Where we're using REST.js so far, in Hub, we have Cedar, as I mentioned before. Cedar has been using not that feature service component I just showed you, but the underlying request to do its queries. And I just merged last night the feature service into Cedar. So when we do our next release of Hub in a couple weeks, it will now pull in the latest Cedar, which will pull in the feature service. And that was a really cool experience, actually, getting it into Cedar, because Cedar's written in TypeScript, so this is the source code for Cedar. And for one thing, I was able to get rid of a bunch of code I had in Cedar to handle the different kinds of error requests that might come back. And I was able to get rid of a lot of poorly written tests and replace them with tests that I had to write much better because of all the tooling in REST.js that makes me write better tests. And yeah, and you may be, and the other thing is we get IntelliSense, and you may be wondering, why would I need IntelliSense for a function that I wrote in another library? And I'll just say, it's been a very long week. And this was helpful. I was actually typing in the parameters wrong, and then it came up, and it's like, oh yeah, that's right, Tom. You're right. I need to do it that way. So anyway, if you're using TypeScript, you get these benefits. You get the typings there. I think Dave kind of briefly mentioned this. We have some Ember services to query items and work with groups and administer groups. Inside the hub, we have some Ember add-ons that we've released so that you can already use those in any Ember application. If you were at our workshop yesterday, like if you got to use those. One of the next things we're working on is taking the code that's in those. Most of it's already in, at least in terms of items and groups, is already in REST request. So we moved it over. And now it's just a matter of taking the Ember apps and making them is someone trying to get me off the stage? Taking the Ember add-ons and just making them the thin shells, thin wrappers around these. So we're going to write the code in one place, use it multiple places. We are going to kind of go a step beyond that and take some of another thing that Dave mentioned. We're going to start working on a Hub JavaScript API that could be used internally by other teams that we work with for them to sort of administer Hub entities like pages and sites. And this is just going to go one step above the lower level items and groups, but going to bring in that sort of logic about maintaining the relationships between certain kinds of items and groups. We know that a page belongs to a site, and so when you change one, you have to update the other. So we're going to sort of create a higher level API on top of REST.js. The Deadly Harvester may get a overhaul, may get the REST.js treatment. That's may or may not. John's already been working on taking Esri Leaflet. If you're familiar with that, it does a lot of requesting and getting just requests into that so far, right?
We don't do requests from Esri, we do demands.
So that's already in progress, and we've had some great help from the community there, right? So that's pretty cool. That should be coming soon. And then we mentioned the developers.arcgis.com site. They have been waiting for me to get this conference-driven development first draft of the feature service package out so that they could start working on the administrative end of things. So we expect good things there. And beyond that, it is open source. It's on GitHub. It is there for you to explore and hopefully start. Like John said, we've been scratching our own itch. We're sure you have itches. Not to say that you're itchy people or have rashes or okay. Anyway, we're sure there's things you want to do that is not going to occur to us. So there is a place for you to go and start working on those things, coming up with ideas, collaborating with us. And I honestly don't know if John really wants people to email him or if he's just showing off about his super cool email that he's john@esri.com. I don't know how that happened, but you can email him. And otherwise, you can find us on GitHub. And please, 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 please fill out a survey. Rumor has it if you search for libraries in the app that you will find this talk. And with that, I think we have a few minutes to answer questions. Yes, sir.
Is there, if you have an application or an enterprise, you have to import the URL with every call you do? Is there going to be something like a global config to put it in there once?
So that's not something you handle globally. It's as you create a session, you get an option to pass in a portal URL. So you could maintain sessions in multiple portals, or you could juggle them, I guess is a better way to put it. But you're not obligated within the context of an app or running code to do everything all in one single instance of enterprise, if that makes sense.
Right, and this is one of the use cases that we actually have in the hub. So how the hub works is you have your normal enterprise org, like for the city, and then you get this collaboration org for the community. And so we have this duality where at various points, as an enterprise org user, you have to actually be in both orgs at the same time. So there is, it can be done. It's not the smoothest ergonomics, but you are doing a very complicated thing of trying to juggle identities and swapping them in and out. The passing the portal URL on every request, that's only necessary if you're doing unauthenticated requests. If you're doing authenticated requests, you're going to pass in that session object, and it will have all the identity information it needs in there. So there's the two options.
Is there any planned support for long? So with the geo-processing tasks, I have to wait and ping and wait and ping. Is there any plan to integrate, what am I trying to say, to wrap that so that I could just call it and it would handle all the pinging and eventually?
That would make a great pull request.
Yeah, no, I'm definitely going to scratch it. So just for the record, the question was, so in a promise-based library that gives you a response back, whenever you get that synchronous response, that's not the same thing as handling these services that are async by nature. So there's a request to submit job, you get responded to with an ID very quickly, and then you pull that job. It would certainly be possible to, right now you could make those requests, and then the next step would be to write a wrapper that has internal logic that does the polling and then resolves the promise only when the job's really done. So if anybody wants to do it, everybody else would benefit from it. And we're curious to, we've got some good contributions already. We know most of you are gonna go off and do your own thing, and we'll just hear some success stories. Having worked on a lot of different projects, open source projects at Esri, I wouldn't say disappointed, but I don't get as much feedback, negative feedback, as I'm expecting. So if, don't be shy to say, man, you're missing something that I really want. And we're not just going to say, well, you do it or nothing. I mean, we'll be honest with you about our potential, but also getting started, like the ergonomics of it. If something doesn't make sense in the doc, like we want to improve that developer experience so more people can get started with it and be successful. So don't be shy. Even if you say, man, I just got started with this and I don't know what I'm doing, we want to hear about that too, because we want to solve those problems.
Right. And I would say a lot of the forcing function right now is the needs that we have within the hub. And we currently are not doing much geoprocessing, but that is another wave of things that we want to bring in, is how are we doing analytics on top of what's going on. I think as soon as we hit that, we are going to have exactly that problem. And then one of us will probably, or maybe John, write the wrapper to abstract that. So you make your GPU request, and it's going to sit there and fire and fire and fire, but all you got to worry about is the final callback.
And those things are, the network analyst stuff will benefit from that, and what we do with items, there's a lot of these things are transferable, so we're fleshing out the library will help those other tangent use cases too. Yeah?
Does the session support IWA?
We're pretty sure. I
don't know.
It should. The hub application is using the same infrastructure for this, and it does use IWA. So I don't think that there's anything in here that would prevent that. But obviously that, it's a use case we haven't tested heavily yet. So we'll find out. The hub ships with Portal. It's not turned on, and you have to license it in a weird way. But we are in the box, so we have to be compliant. So nobody's griefed us yet.
Yeah, I know there's support for kind of like refresh tokens and some of these other idiosyncrasies of authentication that are kind of a bear to handle on their own. So part of me wants to say yes, but it's just because I haven't done it myself, I'm hesitant to. Dave's more optimistic than I am. Way in the back.
Is there any plan to support like the geo-enrichment
we like Dave said, we don't have any use cases that are driving that to give you a timeline for it. But at the same time, like it would be really easy for me to write up a demo, like the way that we do geocoding. You know, I'm not the strongest developer in the world, and it didn't take me long to write that lib because it's pretty bare metal. So if you wanted to make a routing request in the lib, we're basically just kind of wrapping this fact that you want to do like a closest facility or you want to do like one of those other kinds of routing requests. It's up to you to create the feature set to pass to it and get the response. There's not a lot of logic inside, so it wouldn't be hard for us to do it because it's still just a small building block, if that makes sense. So saying that we have support for geo-enrichment, we could make a pretty thin wrapper and make it useful. That wouldn't be a complete solution for every single operation and every permutation for how you might call it, but doing it, you know, at least a proof of concept wouldn't be much. Anybody else? All right. Thank you so much for coming. It was great to see a crowded room.